Hi everyone, welcome to the video lecture on duality in networks. As the name tells you, duality means there is some double role involved, right? Yes. Now, basically in electrical circuit terminologies, dual network means two electrical networks. If their mesh equations of one network is equal to the node equation of the another, we'll call it as dual network. We'll understand with the help of a simple circuit diagram. Just have a look at this AC circuit. You can see that you have a voltage source V and there are three impedances connected in series. This is Z1, Z2 and Z3. So when you apply a voltage, a current I will be flowing into it. That is your current I, right? So this is a series circuit, so the voltages will be different, but the current will be same, correct? So when you apply KVL, what you will get? You will get like V is equal to I into Z1 plus I into Z2 plus I into Z3, the sum of all the drops. So when you group it, what will you get? It is V equal to I into Z1 plus Z2 plus Z3. So in this case, we have applied KVL to this circuit, to the network A. Now let us take another network like this. This is, let me name this network as network B. Here instead of voltage source you have current source I and you have admittances connected in parallel. So we usually represent admittance by the letter called capital Y. Y is nothing but the reciprocal of the impedance, that is Y equal to 1 by Z. So we have here a current source I and three admittances connected in parallel. So this current I will flow in three different paths. So I am naming it as I1, I2 and I3. So when you apply Kirchhoff's current law, so incoming current equal to outgoing current. So capital I equal to I1 plus I2 plus I3. So what is actually I1? When you want to apply your Ohm's law, what is I is equal to V by R, correct? 1 minute. So when you want to apply your Ohm's law, it is actually I is equal to, if you talk in terms of impedance, if you talk in terms of resistance, it is I equal to V by R. In terms of impedance means it is V by Z. So what is 1 by Z? I told you impedance and admittance are reciprocal to each other. So 1 by Y is Z or 1 by Z is Y. So here 1 by Z I can replace it as V into Y. So with that note, I can replace I1 as V into Y1, I2 as V into Y2, and I3 as V into Y3. So when you group it, you will get I equal to V into Y1 plus Y2 plus Y3. So now we have taken two different networks, one a series network, another one is a parallel network. So compare when you compare these two, what you are getting at? So when you compare these two networks, it is easy for us to relate their equations. See, you get V equal to I into Z1 plus Z2 plus Z3. So it is almost V is equal to I into Z, correct? It resembles V equal to I into Z, whatever it may be. Let me name it as Z equivalent, correct? Now what about the next equation? It is I is equal to V into, can I call it as Y equivalent? Because Y1 plus Y2 plus Y3, yes. So when you rearrange this, what will you get? When you rearrange this, when you bring this Y equivalent to the left hand side, you will get V is equal to I divided by Y equivalent. So what is 1 by Y equivalent? It is Z equivalent. So V is equal to I into Z equivalent. That means it is clear that from these two equations, both the networks are doing the same function. Yes or no? So in that way, we can, that's why we are calling these two networks as a dual network, because this network, that means network A is one form of network B, or I can also say like network B is one form of network A. That is why we are calling these two network as dual network. Here it is series means here it is parallel. Here it is impedance. So what are the factors related? Impedances are related to admittance and the series network are related to parallel network and the voltage is related to the currents. Okay, right. So we will go to the next slide. So now, anyhow, you do not have studied this in your first 3 units. So anyhow, we'll be covering this equation in the forthcoming units. So just for this time, you understand that this is the voltage equation of a simple series RLC circuit. You have RLC connected in series with the voltage source. So you can see that this is the expression V equal to This is the voltage drop across the resistance, voltage drop across the inductance, and voltage drop across the capacitance. The similar way, if I take a parallel circuit, so instead of R, it will be G, and the capacitance inductance are connected in parallel. Instead of voltage source, I am going to have a current source, and this is the current equation. Okay, so the current flowing through your resistance or the conductance, the current flowing through your capacitance, and the current flowing through your inductance. So when you compare these two circuits as in the previous case, you can easily relate that both the networks are dual networks. So from this, it is very clear that we have got a set of dual terms. The current and voltage can be a dual term, open circuit and short circuit, inductance and capacitance, resistance and conductance. G is nothing but conductance, series and parallel circuit, voltage source and current source, and KCL and KVL. Okay, this is a special feature which you can see in your electrical networks. Thank you.